Hello friends, welcome back. Let's now focus on transmission of data between the two nodes that we had created in the previous experiment. So basically when we create the nodes, we created two nodes. When we created two nodes, by default, NS simulator in its environment, in the node it will have Ethernet and IP layers in it. So, for example, when you create Ethernet and a node, it had these two layers: physical data link and the network layer by default. And what we are supposed to do is now add these layers, whichever layers we want on top of it, those protocols that we want on top of it. For example, in transport, we could add TCP or UDP and subsequently the appropriate application at the sender side. Likewise, at the receiver side also, when the node was created, only these two layers were available. We had to create one of them and the appropriate application, the receiving applications on the receiver side. So having said that, here's the script for that. And in fact, if you observe, it's almost the same that we had created in the experiment 1. The starting and the ending should be the same. And the middle content should be added afresh. So let's just look at that. We'll focus on the middle part add-on. So let's minimize this and then we'll get to the Ubuntu environment. Let me put it to a side. We have the Ubuntu environment in the background. I am able to see the script in the PPT, whereas even if you don't see it, don't worry. So since I'm typing it, you can have a look at it. So we say let's first copy the previous experiment that we had done, experiment 01.tcl. Let's make a copy of it. Let's call it as experiment 02.tcl. Good. Then let's do a gedit experiment 02.tcl. Start it with the ampersand. Okay. We have the previous one that we had created. Everything is fine. So now after the link has been created, and then let's add this additional sections. We are creating a UDP basically protocol at the transport layer. In network simulator NS2 parlance, it is called as agent. So we are creating a UDP agent and calling it as UDP 0. And then we are telling NS that attach this agent that you have created, that is the transport layer that we have created, to node 0. And what is it to be attached? UDP 0 that we have created just now needs to be attached. Then let's create a CBR. It's application, constant bitrate application, and name it as CBR 0. Let's say new application traffic and CBR. This is the way the class is invoked and the object has been instantiated. And this further, we need to, this CBR 0 that has been created needs to be attached to the agent that was created before, and we had named it as UDP 0. And then finally at the receiver side, let's call it as transport layer UDP as null agent. In fact, at the receiver, when you create a at the sender, when you create a CBR agent or UDP agent, the corresponding agent at the receiver is called as null. So we called it as null. And then this we are supposed to attach it to the receiver node, that is basically N1. And we are supposed to attach what we have created, null 0. Fine. So we have the transport layer at the sender and the transport layer at the receiver created. Now let's create basically a source now. Or yeah, let's create, before TCP part is also there. Let's keep the TCP part aside. Let's just connect this we have created the agent. Let's connect the let's connect the NS, the source, and that is the source UDP 0 and the corresponding null that is there. We attach it to the null. We have created the UDP transport layers both at the sender, receiver, and we have created a application on top which is CBR. So this completes our script. And then finally, let's say, let's give the simulator 10 seconds time. So we have made it 10 seconds. And let's now say start NS at a 1 second interval. How do you start it? So we started saying start the CBR 0, that application was created, started it at 1 second, and then run it till say 8 seconds, and at 8 seconds we say stop the CBR 0 application, in the sense like stop sending the traffic till that, start it at 1 second and start sending till 8 seconds and stop it, and after that the simulator stops. Another thing that I missed telling is basically the trace file. So we want the trace to be written in new files now instead of the old ones, so that they are not overwritten. So we are giving it as experiment02 just to be consistent. You could have given any name over here, but to be inconsistent of what TCL script is there, we are using the same name .tr and .nam. So let's save this. If everything is fine, we should have compilation go through. Let's get to the compiler. We compile it by saying, let's type it. We call the ns shell, and then we give experiment02.tcl. If everything is fine, good, everything is fine. So it has got compiled, and in the background we can see that new files have been created. Experiment number 2.tr, experiment number 2.nam has been created. So let's visualize what has been created. So to visualize, we invoke the animator, experiment02.nam, enter. So we have the nam coming up, we expand it. So there are a few options that the nam gives. So let's organize it a little bit. We can say edit, and just to keep it in line, just so that we can see the animations properly. Let's keep it in line. Yes, it is in line. And here are the play button. We play it, and we can see that the time is now scrolling. Time is scrolling, and we said at the start of 1 second, the application is to start submitting the or sending the packet. So 1 second is here. Once the time scroll bar comes here, the packet should start flowing if everything is right. Let's wait for it, and then yes, you can see the packets flowing. So if you want to keep it in slow motion, we can just scroll this bar, and then you can see the steps now is in just 50 microseconds. So you can see the CBR packets flowing or the frames flowing. If you want to speeden it up, so we can just speeden it up. So this is the visualization, first visualization that we are seeing. We created 2 nodes and a link, and then we put the application here. It's using UDP, and then that is sending data. We had application, we had a UDP agent here, receiver basically. It's receiving them successfully. Good. So this is the NAM file. So let's minimize this, or we can just finish this off. So just by scrolling the whole thing, it will finish the whole simulation off. Whole simulation is over. So we minimize this, or we can close this off. We close it. And then what about the NS file? So let's also exit from here, quit. So we had a TR file. So there is a TR file generated. If you do a listing of the TR file, cat TR, you can see all these entries that are there. It indicates each packet, which time it has been, what time it was generated, where did it get generated from, what type of it is. So all the history of the packet is there. The first one indicates it was received, plus indicates added to the queue, minus indicates removed from the queue. In fact, these formats we can get it from the standard document. So all the statistics of how many packets were simulated, we have it in the TR file over here, experiment02.tr file. So we have a awk file. In fact, we got it from the Telangana government. There is an education body. Thanks to them, we have got this awk file. So let's invoke this awk file. The way to invoke this awk file is called the awk shell script. Give it the script that we want to execute, and what is the file it needs to execute on, experiment02.tr. Hit enter, and then this script, as you can see, it has found out that it had basically so many sent packets, 1867 sent packets, so many received packets were received successfully. That's the reason there are no drops in the packet. Delivery is 100%, and the drop ratio is no drops are there. That's why 0%. Overall time, delay, and all the statistics, what is the throughput and everything, have been extracted from the .tr file by using the script, awk script. In fact, if learners or the viewers are interested, they could use any other programming language to extract this statistics. They can use R, or they can use Python, or the latest programming language, whichever students or with viewers are comfortable with. So all we need to do is next thing we need to do is we need to capture these values, write down these values in the parameters that we are seeing over here, the table that we are seeing over here. So with that, we'll stop here. Thank you very much for watching this. We'll subsequently build upon these small experiments. Thank you.